Hello. So today I'm using Lua to find biggest number in a nested table. You can see in the problem statement. Ignore these things because it was totally empty. The slide was totally empty. So I put these random pictures here. So let's move on to our table. So you can see this is our table. It's quite tricky, There's tables inside of tables. There's string. There's boolean. There's this boolean value. So to find the maximum number, we can't use a normal loop because it's not a simple table. It's like there's table inside of table, there's string, the loop. So normal loop like this for loop or while loop, these are not enough. We need recursion. What is a recursion? Recursion means a function calling itself to solve smaller versions of the same problem. This, so you can see the data types. These are tables inside of tables, like this boolean value, this string value. So you know so the function must decide what I should do. The functions the function should only care what the function should only care is the numbers, because it has to print the highest number. But there's string in the table, and of course there's these boolean values, and of course there's table inside of table. So the function has to find its own way. So the function starts in this local find max item. I created this local current max equals to 0 to keep track of the biggest number for inside the current level, right? So this is I used if this type item is equals to number, then return item will be returned back. Okay, then we'll move to else if. What if it's not number, if it's a table inside of table? So what it does is we will use else if item equals to table. As you can see, if it's a table, then what it does is the table does not directly find the numbers in, because you can see there's this table, like it goes inside, and there's another table, and there's another table. So it's quite a tricky one. So for of course to finding the values, we will use for loop. So what for loop does is, this is the index, this is the value in I pairs item do. Of course we have applied this for loop. Then there comes this recursion. So what recursion, look at this, local tmax equals to find max value. So if it's a table, of course it will find the values. If it's a number, then it will go back to here and the return item, right? And if it's a table, then again it will go back here and use again this. And so this is what recursion does, like, right? It keeps on going inside and inside and inside and inside to find the numbers, because we can see what we need is numbers. We don't need anything else. These boolean values, these table values, we don't need any of that. So right, this is the number. So then of course after finding that, so so let's see what this TL max does. Take this TL max. What it does is it stores the biggest number found inside the particle value, right? If there's the biggest number, it will store inside of it. It will find, let's like see, like it's 1 2 3 and 4. There's this table and there's this table inside. So first it will, like, it's a number, so first it will check this. Of course it's a number, so it will return. So this current max becomes 1, right? And so and again it moves again. So it's a table. So in table you can see what it does is it uses for loop to find this function find max value, and it follows this. So fi- it uses recursion. If 2 is bigger, the TL max becomes, I guess, 2, right? Then again it goes further, right? And TL max becomes as for loops again applies, and this TL max becomes 3, and 2 and 3 is greater, so 3 is finally chosen. And then we move again. So you can see it's a normal number, it's not a table. So here it comes, so return item. So here it was 3, here it was 4. So of course 4 is bigger, those this TL max becomes 4. So what it completely compares all the value and keeps on updating this current max and TL max. This TL max, it keeps on updating it, right? So of course this return, yes, if TL max is bigger, then the current max is here is 0. We have already put that the current max here is 0. So of course TL max will be bigger. It will go and find whatever is big, and this current max becomes the TL max. So we keep on updating the current max according to whatever TL max has found big inside of the table. So of course we end this loop, and we end this and this and this, and it returns current max, right? And after this, the local result, of course we'll then print, and this is the final print. Thank you. Question, but this time we use a different method, right? Of course the table is same, but we are using this global variable. This what the, so so the previous version, as you can see, the function return values back the recursion. This it was written back, but in this version, of course, I'm using a different strategy. I can't use the same. So I made a variable called current max. This time it is outside the function. Last time you can see it was inside of the function, and this time it's outside the function. So the variable is shared by the whole program. So instead of returning the answer for each recursive call of the function, it directly this function directly updates the variable whenever it finds a larger variable, right? So this approach still uses, of course, it uses recursion, but the style is different. The recursion is only used to visit every nested element. The actual answer is stored in one common variable, right? So of course this local current max is set to 0. We are using this local function find x. Of course, if item equals to number, like if the item is equal to number, then we compare it here and here only, right? So if this item is bigger than the current max, of which of course it will, because like see the first number, it is 1, it is an item. If you see this, of course it's a number, but it's a table inside of table. So we'll have to use this else if type item equals to table. Then if we have to find this as, because this is not a number, this we will call this as a table because it's inside of table. To find the number, we have to go inside the table, of course. So for that we will use else if, and to find the element or find the value, we will use for loop. So you can see this for loop here. For loop this is the index and value in I pairs item, of course whatever the item is, and we'll use this recursion again to find the value, right? This is recursion is. So what it does is it goes inside the table, right? And if there is the like this is the value, right? This is index 1, this is, of course it becomes another table. That it so its index, this table's index is 1, and this table, I guess it ends here. So this is table is 1, right? So what it does is it goes here, it finds if it's a number, then it's an item, right? And if the item is bigger than current max, which of course it will be, because the current max is 0, so the current max becomes item, right? So it keeps on doing this. It goes on here, goes here, goes here, goes inside of tables, all the tables. It goes, it uses the loop to find the table, and if it keeps on updating the current max, because it's a global value, right? Not like the last time. It was not inside a table, so or not inside the function, right? It's a global value, so it keeps on. So the function starts the this is our base case, right? Mm, so this is what it also. What about the strings and booleans? What it does, right? We also didn't answer this last time. We'll answer. What about this? Because we used this different function here. We use a different function here. What about these things? These booleans and these strings. So number condition, not the table condition. So it is basically ignored, right? It doesn't matter, because either only numbers or tables matter, but it's a boolean or a string value, so this code doesn't care about, right? So of course the final call and print, and it will be printed. So if a question is which one is better, what will the experts choose? This one is the variable inside of the function, or this one, the variable is outside the function? So the experts will choose this version. Why? Because it's clean, it's modular, it's predictable, it's usable, it's safer, right? No external is safe. Here the function is self-contained, whereas the second version, the function depends on current max. Outside of it, it means it's less clean. Whereas first version you can call it's just easy, basically easier to reuse, and if it's not easier to, or the style is better here. It's small parts, return result upward and combine results, and here it this is also less bug prone. The second version can be, this version can be create bug if we forget to reset this current max or another, right? If we write a code, there's a bunch of codes, a bunch of functions, and if we try to use it again, this will be a problem if you use it a multiple time. So in the first version, each recursive call returns its own maximum value, and those values are compared step by step. That is cleaner and more modular approach, right? In this version, it is easier to understand, but it is less elegant and less reusable. The return based version is more professional because it avoids internal state and makes the function reusable. So basically, this one is better because it compares step by step, and it stores one time and then compares which one is bigger, right? Thank you.